integration by U substitution. So working backwards, but sometimes the answer we're looking at looks complicated, and we need to make it look better so that we can underive it. So we can, put the car in reverse and back up. All right. When you take derivatives of more complex expressions, you frequently have to use the chain rule. That was in the 3 examples we did. And when you use the chain rule, then you get that extra stuff tagged on to the end. The integration equivalent of the chain rule, so like how to go backwards with the chain rule, is U substitution. It allows you to integrate more expressions. The U is arbitrary, meaning you could pick any variable you want. Everyone just picks U, but you could easily call it V substitution or W substitution or any letter you like substitution. But usually we just call it U substitution. The big deal is you have to replace all X expressions with U expressions. That's should probably like highlight that 3 times and star it and everything else, because the mistakes will happen when you go halfway, when you substitute part of your X's and you end up with an integral of X's and U's. That's definitely, you can't even do that. So when you commit to switching to U's, you got to make sure all of the X stuff is replaced with U stuff, and hopefully it makes it an easier integration to do once you make that swap. I guess the hard part about U substitution is the best way to get there is just lots of practice to start recognizing what's best for you. Probably the first and easiest hint is, we'll start kind of gathering these hints as we go. You want to try to pick U so that du shows up. Pick U so that du is also part of the problem. Again, the more of these you do, the easier it becomes. So on this first one, x times x squared minus 1 all to the 5th. I'm going to let u be the inside part, x squared minus 1. If that's u, then the derivative of u, what's the derivative of x squared minus 1? 2x. Okay, well that's sort of there. Maybe we should have said so that du sort of shows up or mostly shows up. Because usually it doesn't match up perfectly. Usually you get close. You're like, well, I really wish that was a 2x there. Actually, let's do this a little bit more formally here. I'm skipping steps. We wouldn't just say that's du. We would say du dx. Right? Like dy dx. But this is du dx. So that means du is... Okay, du dx is not a fraction, but we sort of treat it like a fraction. So it's wrong to say this, but it's what we do and it's what makes things work. You can multiply both sides by dx and get the dx to the other side, which is kind of strange because that's not really a fraction, but you can treat it like a fraction. That's just the easiest way to say it. Okay, so I'm looking at what I've got. So this is u. 2x dx is close, right? It's like I'm almost there. I've got an x and a dx. If only there was like a 2 right here. And that probably feels illegal. You can't just like stick a 2 there to make things work. But you've done this before in sort of other places. What could I do to sort of balance out that 2 to make what I just did there legal? Any ideas? What could I put out front that would keep things the same overall? A half. If I put a 2 there, I put the 2 there so that I match up, but that means you can't just go sticking 2's in there. I'm going to put a 1/2 out front. And so now I've got 2x dx. Well, if I put those two things together, that's du. Let's see, I still have a 1/2 out front. And this inside stuff is u. So now I'm going to integrate u to the 5th du. Well, this just got a whole lot easier because now this is just a power rule thing, right? Increase the power by 1, divide by the new power. So 1/2 u to the 6th over 6th. It's been a couple weeks, but there's one more piece to that. Out of practice, plus c. So my answer is sort of 1/12 u to the 6th plus c. Do you know why I say my answer is sort of that? This problem started as an x problem. We're the ones that threw the u's in there to help us solve it. So I can't leave my answer as this. I need my answer to be back with u's in it. But I know what u is. U is x squared minus 1. So now in place of u, I can put x squared minus 1. So there's my antiderivative. If you wanted to check, you could take the derivative and go back and see if you got there. At least you could do it kind of in your head. Power rule would be 6 times a 12th. That'd be a half. Then you'd have x squared minus 1 to the 5th. And then if you multiplied by 2x, the 2x and the half would cancel out, and you'd be right back where we started. The key to all these problems, though, is picking u. Picking u is the hardest part to get used to. On number 2, any guesses on what you think u should be? It's good, 6x minus 1. Another hint about u is you don't want to make it too complicated, because if you make it too complicated, then du turns into a mess. So if you let u be 6x minus 1 to the 2/3, then du is going to have 2/3 6x minus 1 to the negative 1/3. Like, that's going to be a mess. So you want u to be kind of complicated, but not too complicated, because you want du to be kind of nice. So du dx would be 6, which means du is 6 dx. So let's see, I got the middle stuff taken care of. That's u to the 2/3. I got a 4, and I'd like to make it a 6. There's a couple ways to handle this. To me, the easiest is I don't want to try to figure out what I multiply a 4 by to get to 6. I mean, I could do that. It'd be easier if I just stuck a 6 on this. I'm going to put the 6 there, which means I need a 1/6 out front. And then I can just take the 4 out front as well. So I've got 4/6. So the 4 went out front, u to the 2/3, and then 6 dx, that's the same thing as du. So I replaced all of my x stuff with u stuff. And I got rid of a bunch of things, and now it's a whole lot easier. All right, now it's just a power rule thing. Increase the power by 1, divide by the new power. Let's see, simplify 4/6 down to 2/3. So 2/3 plus 1 would be 5/3 times 3/5. Plus c. And then we've done all the hard work. Let's see, the 3's will cancel, so 2/5. I already know what u is, or I know what u is. It's 6x minus 1. 5/3 plus c. This really is just a lot of practice to figure out how to pick u so that the thing works nicely. How about number 3? Any thoughts on what u should be? Especially thinking of, like, what could I pick u to be to make du show up, or sort of show up? Let's pick on somebody then. Gurneer, thoughts? What do you? Good. 2x squared minus 1. Now I'm going to start skipping the step where I say du dx equals. I'm going to just say, I'm going to skip straight to du equals. So Addie, what does du equal?
4x.
I'm going to say, I know what you're doing, but du dx would equal 4x. So I'm just going to skip that step and move the dx over. Okay, so this is pretty close. I got an x dx up there. I'd like a 4 there, so I can stick a 4 there and a 1/4 out front. So 4x dx, all of that is du. Got my 1/4 out front. And then I've got 1 over the cube root of u. But I don't like square roots and I don't like fractions, so how could I rewrite that as a power? Yeah, u to the negative 1/3. The 1/3 is the root, the negative flips it over. And so now I've got again, that's supposed to be a simple power rule problem. Increase the power by 1, divide by the new power. So 1/4. Let's see, increase the power by 1. Okay, Tyler, fraction work here. What's negative 1/3 plus 1?
2/3.
Yes. So u to the 2/3, and then divide by 2/3, but that's the same thing as times 3/2. And I'm a little short on space, so I'm going to risk it and not write plus c and save the plus c for the very end. That's fine to do that as long as you remember to put the plus c on at the very end. So let's see, that's 3/8 u to the 2/3, but u is 2x squared minus 1. And then don't forget the plus c. So we took a couple of smaller shortcuts on that one. We didn't write du dx. We just wrote du and stuck the dx on the other side. And then I held off on the plus c until the very end. So 2 easy things to save a little bit of time. All right, number 4. We're getting a little more complicated here, maybe. But not too much for Lauren to handle. Any thoughts on what du should be? I'm not du. What u should be? When you say the bottom, do you want to include the squared or not include the squared?
Is it up to preference or?
Okay, that's a great question. The question was, is it up to preference? Kind of, but one preference leads to the right answer. Like there's if you put the squared on there, it's not going to work. Okay, so I guess I should say it's not up to preference. Okay, like you could pick it, and if you put the squared on there, I think you would realize pretty quick. I switched to pencil, so don't write this down. When it came time to find du, it would be 2 times all of this times the derivative of that. That would be a very complicated du. So you want u to be kind of complicated, but not so complicated that du is crazy. So you were absolutely right to be looking at the right thing and thinking, like, well, do I need to include that squared or not? And the answer is no, because if you did, du would be crazy.
Would it change it such
if you let u be the top. So I don't mind doing this because when you start doing these, it's like I automatically know how to pick so that it works out every time. But you guys are going to spin your wheels sometimes. And even if I see a new one that I haven't seen, then it may take a couple of guesses to figure out. And so I will frequently see wrong guesses on people's paper. So if u is x plus 2, what is du? Oh, wait a minute. I saw, okay, 1 dx. And it's like, well, that doesn't really help me, right? Because I could replace the top in the dx, but I'd still have that denominator down there. So there are plenty of times where you will false start on u substitution, and that's okay. Realize, whoops, that didn't work. Let me go pick a different u and see if it works better. Okay, so I got the bottom to be u. Whoops, that should be 2x plus 4, not 4x. That's not exactly the top, but could I make that the top match that? If I put a 2 out there, then it would be 2x plus 4, so 2 and a 1/2. And so now all of this numerator is du. And then I've got 1 over u squared. I advise against trying to integrate that because if you increase the power by 1, you end up at u cubed, but that's not right. It would be wise to rewrite it like that. Then increase the power by 1 because, Mia, if you start at negative 2 and you add 1, what do you get? Negative 1. So this would be 1/2 u to the negative 1 divide by negative 1. So let's see, that's negative 1/2 x squared plus 4x minus 3 to the negative 1, which that's not wrong, but I suspect it would probably be written in the denominator like that. And then what am I missing? Plus c. Again, first time through, you're probably going to misfire on picking u. So if you pick the wrong u and you start working the problem and things aren't working out, it doesn't mean you did something wrong other than picking the wrong u. So sort of reverse all the way to the beginning and see if you can figure it out. Okay, number 5. Number 5 is, if we had more days to spend on this, we would put number 5 on a different day. So if you look at number 5 looks weird, you're correct. Any guesses on what u should be? There's really only a couple of things to think about. So if you let it be the square root of x minus 4, then you'd have 1/2 x minus 4 to the negative 1/2 times 1. Okay, so that the u would be great, but the du, like, I don't see anything with a, right? So it wasn't a bad guess, but du got too crazy, so let's not do that one. But that is the usual first guess. It's like, well, let's fix the complicated thing and hope the rest works. Well, if that was too complicated, then I need to pick something less complicated. So let's go with u equals just x minus 4. So du is dx. It's like, well, okay, that doesn't do me a whole lot of good. I'm going to write the step down that it's not wrong, it's just not really, right? Like, this statement is not wrong, but I can't do anything with it because I've got x's and u's in there. So it would be helpful if I knew what x was equal to so that I could get rid of this x. Well, if u equals x minus 4, This is like a double reverse trick play problem here. What's x equal to? U plus 4. So in place of x, I can put u plus 4. So this now is u plus 6 times the square root of u du. Well, that's not great, but at least it's all in terms of u. And even though it looks pretty similar to what we started with, you're like, well, did that really improve anything? I can distribute the square root of u now. So I guess I could have up here, but it wouldn't really help anything. So let's distribute that square root of u, and I'm going to switch to powers rather than roots here so that I can integrate. So that's u to the 3/2 plus 6u to the 1/2. And now this is supposed to be an easy problem. Increase the power by 1, divide by the new power. So u to the 5/2 times 2/5 plus u to the 3/2 times 2/3. It's occasionally tempting to leave it like that because we did all the hard work. We did the integration. What's not right about that? There's two things not right about. One is the plus c. What's the other thing that's not right? It's still in terms of u. And so it's not wrong, but this problem is an x problem. So I need to replace my u stuff with x minus 4. So 2/5 x minus 4 to the 5/2 plus, let's see, all of that would be 4 x minus 4 to the 3/2 plus c. Ugh, I don't like those. Those always throw people off because of that reverse substituted back in thing. And because I don't like it, number 6 is pretty similar. Thoughts on what u should be, Quinn, for number 6? Follows a similar pattern as number 5.
X minus 6.
Good. Just x minus 6. Because if you picked it to be the square root of x minus 6, du would be a mess. So let's just let u be x minus 6. And then du is just dx. That's easy. So part of this is great, right? I'm going to switch that to u to the 1/2 in the bottom rather than the square root. Again, this statement I have written here is not wrong. It's just really ugly because I've got x's and u's in there. Lauren?
Will there be times when using the square root for u works out? Or do you always want to avoid it?
There will be times, but you would recognize it because there would be other square roots in the problem. Like on this one, it doesn't work because the du would be awful. It's all about, really picking u is more about thinking ahead to what du is. So you pick u based on du, which is kind of tricky because you don't know du until you have u. So your derivative rules have to be pretty quick so that you can look at u, know du, and then realize if it's a good pick or not. Okay, I've still got an x in the numerator here. What is x equal to? U plus 6. So I'm gonna see u plus 6. Trying to save space here. U plus 6 minus 5 would be u plus 1. All over u to the 1/2. And now I can divide both of those by u to the 1/2. So u to the 1/2 plus, hey Ava, what's 1 over u to the 1/2? It's like u over u to the 1/2 is u to the 1/2. 1 over u to the 1/2 is Why is it in the denominator? It's negative. U to the negative 1/2. Okay, now we've done all the hard work. Now we shift to what we're supposed to know how to do, which is the antiderivative stuff. So increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. About one person per class is going to leave that as an answer on a test because they feel confident they did all the things right and they did all the hard stuff. And they're right. They did everything right and they did the hard stuff. But it's not over yet. You got to put x minus 6 back in for u. And we need a plus c at the end. We mentioned earlier, like you can take a derivative of your answer and see if you get back to the original, but that would be a real pain for this one. It wouldn't. I mean, it would work. It would just take longer to check it than it would to do the problem. Number 7. Okay, 7 in some people's minds is going to be an easier problem than those last two, because forget about the 4x for a minute. Who has a derivative of cosine? Like, how do I go backwards from cosine? Is it positive or negative sign? Positive, right? The derivative sign is cosine. The argument's got to be 4x because that can't change. But there's still something not quite right about that. Because if I took the derivative of sine of 4x, I would get cosine 4x times 4. So in order to sort of undo the times 4, I could just put a 1/4 out front. Now, that's the way many of you are going to eventually do this problem. Do you know what, if you wanted to work it as a u substitution problem, what u would be? There's not really much of a choice here. 4x. You don't want it to be cosine of 4x because then du is sine and then that's too complicated. So I need a 4 dx, so I'll put a 4 on there and a 1/4 out front. And then I've got 1/4 integral of cosine of u du. And the antiderivative of cosine is sine. And I put 4x back in for u. Again, but a lot of people are not going to show the u substitution on that. They're going to just sort of account for the 4 on their own. What they're doing is u substitution. They're just kind of doing it in their head. Thank you very much.
I was able to make copies of the notes, but there's too many people down there to make the worksheet copies.
Okay.
So I just left those copies there.
Awesome. Thank you.
Uh-huh.
8's pretty similar to 7. So ignore the 10s for a minute. What has a derivative of tangent secant? There's a trig function whose derivative is tangent secant. Which one is it?
Secant squared.
Not secant squared, just secant. The trick is the derivative of tangent is secant squared. But the derivative of secant is this. So to undo the tangent and the secant, I would get back to secant. The argument would still need to be 10x. But how would I fix that? Like if I took the derivative of this, I'd get tangent 10x, secant 10x times 10. In fact, here's one. You could sort of fix it on the fly. There should be a 10 there, but you can't just go putting a 10 there. So you put a 1/10 out front, and you kind of do u substitution without showing the u's. Okay, that's if you recognize that what's there is the derivative of a function that you know. By the way, we're almost done because these the bottom half is for Thursday. So 2 more. Okay. Number 9, sine cubed x times cosine of x. It's like, wait a minute, there's no trig function that I know of where that is the derivative. So I definitely want to pick u so that du shows up. Now this one's kind of tricky because if I let u be sine, derivative cosine, and if I let u be cosine, derivative sine. So it's like, hey, I could maybe go either direction with this. But based on what we've done previously, do you know what we should let u be? Right, remember, that's what that means. Let's let u be sine of x. That will simplify this cubic thing. And derivative sine's cosine. So this cosine x dx stuff, that's du. And so I've got u cubed du. And so the thing looked really terrible at first. We picked the right u, and it's pretty easy now, or it should be easy now. Increase the power by 1, divide by the new power. Again, don't leave it like that. Put the u back in there. And don't forget the plus c. And I feel like that one would be easy to check. If you took the derivative of this, 4 times a fourth would go away. And then you'd have sine x cubed, and the derivative of sine would be cosine. So yeah, you'd be right back to where we started. Number 10, Tyler, I should call on you for this one. What do you want u to be so that du shows up? What could we let u be so that du shows up? So you said secant squared, but I don't want u to be secant squared because then I would have the derivative of secant squared would be 2 times secant tangent. That'd be kind of a mess. But I do recognize that secant squared, I'm kind of working this one backwards. What's secant squared the derivative of? Tangent. So if I let u be tangent of x, then that whole second part there is my du. And so this sort of goes with what I said earlier about you pick u so that du shows up, but you don't really know du until you pick u. You've got to know your derivatives well so that you can recognize what's going on these. So secant squared x dx, that's du. Tangent was u, so this is u squared du. Wow, that just got a whole lot easier, a whole lot quicker with the right pick for u. So 1/3 tangent cubed x plus c. Practice, practice, practice. You've got to practice these so you start, well, you got to know your derivatives well, and you've got to practice picking u so that du shows up. All right, we're going to stop there. The rest of them you might be able to figure out what's going on, but that's tomorrow. So let's stop there, and I'll pass out worksheet 1.